Proved. Show me. Proved, but this much don't want. This and all. Why here? Let have, choose have. Why choose delta is equal to epsilon by k? This is very good. You hard work did. Thoughts are good, but this much don't want. And direct you can't choose here like that because of your.
Actually here after coming this value, here I got what if I give delta value, then this will get cancelled. That then only I chose that.
But you can't choose reverse no. What you want?
Like that we followed in our always.
No, you can't follow. What research? Always you think this is first time going to happen. What you want like that before you choose, that is not good. No? You want here epsilon by k. So before you choose delta is equal to epsilon by k. That is not good. Suppose you are first time you are proving. What is your name? This is Nivashini condition. Then correct. This type you can't go like that. This is wrong have here, and this much you don't want, but very good explained. Okay, but that is wrong. Anybody same have or different? Show me. You did this. Where replace got correct. Same only. Then show me. You told different. Return I want.
So if we replace k delta as epsilon,
You have to proper explanation
yes,
have to
yes,
give.
right. Same as the previous.
Hey, you not doing. Why? You did, Roshan? Then take rest. Here, by definition itself, you can prove direct. For uniformly, that only uniformly continuous function also same definition only. Function is Lipschitz function. Lipschitz function means function satisfying Lipschitz condition. And for uniformly continuous function, x1 minus x2 less than delta given here. This is always given here. And this k delta only will be the epsilon value, and this is will be the just completely constant behavior. Already we proved yesterday some question and all. Same only this also exists on earth everywhere, whatever domain they will give. So finally f of x1 minus f of x2 mod less than epsilon whenever x1 minus x2 mod less than delta. Okay. Therefore, Lipschitz function on domain D must be uniformly continuous function. On same domain D. This is the just can tell depend on definition only. Right, everybody? K is greater than equal to 0 any finite value only, and delta is completely depend on epsilon. So K delta direct you can write epsilon, no problem. There epsilon need, for that epsilon place you will put delta by k cancel, no need that. Epsilon is not exactly any value. Epsilon is just one point. How much you will go, that will increase. You can't tell that okay 2 epsilon is greater than epsilon, no. Epsilon is less than 3 epsilon, or epsilon by 2 is less than epsilon, you can't tell. All are epsilon. Understanding? Just God anything have? Everything, whatever you will tell about that, everything okay, like that. No need that epsilon 2 epsilon have, so epsilon is greater than less than 2 epsilon. Direct epsilon rate. No measurement about epsilon. That is for uniformly continuous, always given have. Whenever meaning what? Yes, whenever. When you want, you can use that and can make uniformly continuous. So x1 minus x2 given delta have. If that not given have, means we can't proceed. Okay. So Lipschitz function is always uniformly continuous function on domain D. How to verify any function is Lipschitz function. We saw sin x function, no? Sin x function will be Lipschitz function. On domain D. D domain we will discuss. Lipschitz function, how to verify that I am learning you. Not uniformly continuous. Uniformly continuous already we saw this is sin x function. Sin c minus sin d formula. Here k value is 1. So finish. So f of x is equal to sin x is Lipschitz function. Where Lipschitz function? Everywhere. Okay, here no any problem coming, no? If suppose here k plus x1 x2 form, anything will come, and you will see that x1 x2 infinity I will approach, then Lipschitz fail going, so infinity is not possible. Means same type, at which point fail will go, that point will be the can tell non-Lipschitz problem continuity, non-uniform or non-Lipschitz continuity point we can tell. Okay, so like that fail will go, that we no need in interval again. So here no problem, direct one coming constant behavior, so everywhere Lipschitz function. So this is Lipschitz function on R. So uniformly continuous function on R. And this k, no, k is called a Lipschitz constant. In definition I wrote like that. No, not writing. This is definition, no. In definition write where k is called Lipschitz constant. Complete. This have to write, no, example sin x right here after. Right, this is finished. Same cos x function also will be the Lipschitz function. Huh? You can try later. Sometime asking on exam hall what is Lipschitz constant, what is the value of k. So whatever will come you can tell. But if function is not Lipschitz, then don't tell not uniformly. Lipschitz function will be uniformly continuous function, but your verification doing coming not Lipschitz function on that interval. That also depend on interval. Some interval, this is how everywhere Lipschitz function. So at which interval Lipschitz function, that interval only uniformly, not other place. we will see root x function. Root x function on domain D. Root x function we can find by more ways. This is the root x graph, 0 to plus infinite. Domain D, but D generalization will come from 0 to infinite, because negative domain not possible because of root. Okay, so here general interval is 0 to infinite. So root x function, monotonic increasing function, continuous also, but unbounded on 0 to infinite. I gave now one example, function is continuous, bounded, monotonic, must be uniformly continuous function. So at 0 to infinite bounded not possible, because root infinity will go, means infinity will reach x tends to infinite. Here I can write root x function is monotonic, continuous, bounded on every finite subinterval of 0 to infinite. 0 to infinite, any finite subinterval, no problem. 0 to 1, 0 to 2, 0 to 10, 0 to 1 lakh, 1 crore, anything. Okay, so must be monotonic. This is monotonic increasing, you can write especially. Monotonic increasing function on 0 to infinite. So I can write that root x function must be uniformly continuous function on every finite subinterval. Of 0 to infinite, either closed, open, anything. But this is not meaning that at infinite this is unbounded have, so this is not uniformly continuous, not like that. Here by one method I told where is this uniformly continuous function. Maybe we will go by definition hereafter. By definition, maybe at infinite we will get anything, or maybe we will go by Lipschitz condition. So by Lipschitz condition we can tell anything. Okay, wait. I am going by Lipschitz first. Next, by Lipschitz condition I am going on domain D, D from 0 to infinite. So this is our value. This is our k value. Any finite value will come. This is less than equal to, I can tell 1, x1, x2 we will approach means. But when x1, x2, 0 we will approach both, or x1 x2 both we will choose 4 or equal to type, then tends to 0 infinite will go, correct? So Lipschitz telling Lipschitz has problem at 0, and whatever x1 x2 you will choose from domain, if root x1 and root x2 both are equal, so that point is the problem. Suppose just like I can choose this will be equal which place? 4 means perfect square place, correct? x1 x2 4 or 9, like that. So that type interval we have to choose. They are not available on our interval. Okay, perfect square not available on interval. So Lipschitz satisfying, I will write here fx is equal to root x is a Lipschitz function on domain D1 from D. And here you see, I think Lipschitz has no problem at infinite. x1 x2 infinite we will approach means no any problem. K0 will come, so no problem. Lipschitz telling no any problem at infinite. So infinite no problem for Lipschitz. But we can't give commitment till infinite by Lipschitz also, because if we will give commitment to till infinite, then any perfect square in between will come, no? Either you go 1 crore, 10 crore, 100 crore, infinite till infinite, infinite types of perfect square is there. So at infinite we can't discuss this function Lipschitz condition or not. Okay. So at that point fail going means on that point not uniformly, we can't tell that is just Lipschitz fail going. This is Lipschitz I solved. So I wrote here both 0 tends to infinite. Okay, then I will choose here where D1 is. D1 what I will choose, then you tell. First 0 plus have before can tell, no, this much I am analysis doing thinking, then here after analysis and change, then not possible, then this is only 0 problem. Then this he found or everybody found? You know this is you? Huh? He only noticed it. Now I will scold everybody, no, for that asking. You can tell before, no? Wait, then little analysis will change. When root x1 plus root x2 have, then 0 is the problem only. Then see, we came at infinite, no problem. Very good. Morning itself, my mind fresh you did.